creating public awareness, if you will, about this technology that was emerging. The scientists were doing their job. From every major university, from Soka University in Japan to Johns Hopkins, Oxford, University of Oklahoma, University of California at San Diego, Georgia, you name it. Every major institute worldwide in January of this year, 2012, presented their findings on a technology called glycoscience. And the title of it was Transforming Glycoscience, a Roadmap to the Future. And of all the research that was compiled and published, their summation is that basically these sugars, well, let me just tell you what they said. They refer to them as the centrality of life, the foundation of life on earth. See, what they're finding is that in sugar, which biology has already known that it provided energy, but when you think about life as a whole, that's what life is, energy. And without that energy, you have no life. So whether it be life within us or life within the plants or life within energy, in how plants convert sunlight, or whether it be in the tensile strength of wood and what makes a tree do what it does and be so strong, it's all based on that energy that is involved in sugars. You know, it even goes on to say right here, I remember in a video it said that you have to have these sugars. You either get them from the diet, you supplement them somehow, or your body has to make them, or they'll plant you in the ground. It says right here, elimination of any single major class of sugar from an organism results in death. This isn't about, do I need these? It's about, if you have life, your body requires it. You know, when you look at all the studies that have begun to come out and everything that they've compiled here, you know, I'll tell you, as I read through this 172-page report right here, there's about 55 pages of nothing but references and involvements, just highlighting the people that participated in this report. The first 40-some pages is all about the implications and the ability to control. You know, a lot of us know the story about, well, a very well-noted person that was stripped of many titles simply by using a performance-enhancing drug. Here it is in the report. And really, what they're actually saying here, despite the potential illicit market in the billions of dollars, no one has yet been able to mimic the natural human glycosylation process. Is the primary basis for the World Anti-Doping Agency test to detect, and it also affects such elite athletes such as those in the Tour de France. And really what they were able to do over the course of time was actually detect an altered sugar and the impact that it was making in the body. Again, you can't fool Mother Nature. You see, there's about 80 pages in here that just talks about the human body and its ability to take these sugars and convert them to support other processes in the body. The bottom line is, as this one researcher said one time, swallow it. The body knows what to do with it. There's a 4-page brief here, and a lot of people ask me, well, how does that pertain to Mannatech? Well, it really doesn't. What it pertains to is the power of these sugars in the human body and what science is beginning to understand. And really, it comes down to what they say right here. And sugars play roles in almost every biological process and are involved in every major disease. And what that's actually saying is in your body, in its ability to recognize things and to function normally at a cellular level. So when we look at Nutrivirus, a glyconutrient technology, you know, it's really an enhancement of what Ambertose began many years ago. And it's just delivering the body with these basic essential sugars that are required for the body to function at a cellular level. It also says in here that all cells have membrane, but not all of them have a nucleus. But at the very heart of that nucleus is something called the laminin, which is the very adhesion that holds a cell together and defines its intelligence. And many people have Googled laminin and have been quite surprised. It goes on to say here, it says that their desire is to create a suite of tools that are, in their term, analogious to those available for studying nucleic acids and proteins. And what that's actually saying is they need to develop tools to look at sugars, natural occurring sources, such as found in Ambertose, to be able to convert them and synthetically produce them. And hopefully, in science, they're looking to make therapeutic drugs out of them. Again, how does that tie to Mannatech? What they're trying to do is purify sugars from natural occurring sources. Again, that's exactly what we're talking about with a jar of Ambertose and, again, Nutrivirus. You know, I've
share this with you. I'll tell you what. I think you will be too by the end of this presentation. Okay, so it says here, cutting edge nutritional science, why you should take glyconutrient supplements, okay? And I'm going to tell you about me just for a minute. I fell in love with Mannatech in 1994. And at the time, I had some experience with science. I have a master's degree, and part of the process of getting an education in a science, at least a graduate education, is you have to learn how to do research. You have to learn how to do statistics. You have to learn how to validate things. So I was always about the science. And I wrote a little book called Networking Types. It's on personality types in network marketing. And there are those people that come to believe because somebody told them a personal experience. There's a lot of people like that. The validation is through somebody else confirming for them what they experienced. I'm not like that. I'm the kind of person that likes the validation through facts. So I studied the science. In fact, back in the day, that was 1994, and you can see Dr. Bill McAnally up there on that screen. We would sit there and the doctors would talk till like 2, 3 in the morning. And we have pages and pages full of notes, and we learned all these different words, like macrophage. Ooh, what's that? And then, oh gosh, there was so many of them. Dehydroepiandrosterol, and then the antigenic statement, and all these things. And I would like write it all down, and then I would go home. And I lived in San Diego at the time, so I'd go to UC San Diego's library and look up these words. So I could figure out what it meant, because I really wasn't a doctor. I didn't know anything, but I did know how to do research. Now, it's still about the science for me. These are recent, I mean, within weeks. Here's one, red and black. I get these on Facebook. It's really cool. So it takes you to this website. Sugar coating, researchers find complex sugars affect everything. They don't say some things, everything. This one here, Spotlight on Glycoscience, and it says proteomics and glycomics and all these words that have the word glyco in them. Then the next one is Transforming Glycoscience, a Roadmap to the Future. Now this here is a brief. See how it says report in brief? Okay, but this one really intrigued me. My brother-in-law, Greg LaRocque, who's a presidential, is also science-oriented. So he sent me this, and I thought it was really interesting, and then he sent me this one. This is the long version. The long version's 209 pages. And man, oh man, was it interesting. So I went through, and I thought, okay, to get us caught up on the science, you guys are laughing. Okay, so to get us caught up on the science, I went through it and I got the highlights. Okay, so let's go through some of the highlights of this. First of all, let's start at the beginning. What's glycobiology? Well, it was coined in the late 1980s by Raymond Dweck, and it was in the Oxford Glycobiology Institute. And now there's a new video online that Mannatech just put up on the history of glyconutrients. They talk about this being in the dictionary in 1988. It originates from carbohydrate chemistry and biochemistry with a modern understanding of the cell and molecular biology of glycans. Now there's a word I did not know. Here it is, all these years later, new word. And in particular, the conjugates. Conjugates. Well, that's their connection between proteins and lipids, which are fats. Okay, the next one is all these different words. Carbohydrate, glycan, saccharide, or sugar. Well, it turns out that a carbohydrate is a generic term that's used interchangeably with all of these different ones. A glycan is a generic term. It means any sugar or assembly of sugars in free form or attached to another molecule. Saccharide, a generic term for any carbohydrate or assembly of carbohydrates in free form or attached to another molecule. All sounds the same to me. Sugar, a generic term often used to refer to any carbohydrate, but most frequently to low molecular weight carbohydrates that are sweet in taste. And there, lies some of the confusion, because the carbohydrates we're going to be talking about today are not sweet in taste at all. So ta-da! These are glycans. Now, how many people have seen those little structures? Any of you that's been in Mannatech for a while? Did we ever call them that? No. Turns out that a glycan is the sugar part, and then down at the base is either a protein or a fat, or even sometimes a, what do they call that? Like DNA, nucleic acid. Okay? So then it talks about the importance of glycoscience. And as I go through this, you're going to see this little red thing up here. I'm not saying this. This is stuff I took out of this report, which you can get. Okay? Mannatech isn't saying it either, by the way. Glycans are one of the 4 fundamental classes of macromolecules. Okay? And not only that, the other ones are nucleic acids, proteins, and lipids. And they're made up of individual sugar units linked to one another in multitudes of ways. Understanding the structures and functions of glycans is central to understanding biology. This is huge. This is comprehensive. This is big, you guys. Okay? Now, glycans are ubiquitous. Well, when I was in high school, one of my teachers said ubiquitous, and I'm one of those people I want to understand. So I raised my hand. What's ubiquitous? And the guy thought I was being a smart aleck, you know. And I said, no, really, I want to know. It means everywhere. Ubiquitous means everywhere. All living cells are coated on their cell membranes with glycans, or include glycan polymers, da-da-da-da-da. Okay, there's a little picture down there. The next one, they play diverse roles, including critical functions in the area of cell signaling, molecular recognition, immunity, and inflammation. How many years have we been hearing that? And if you're new, where's the camera? Hi. So if you're new, this may be new to you, but it is huge. It's really important. Glycans are attached to specific locations on many proteins, modulating aspects of their biological activity through molecular recognition or affecting their circulation time in blood. All right, now don't fall asleep, because I'm going to get to more exciting stuff, but we got to do our definitions first, okay? All right, so facts about glycans. They're the most abundant family of organic molecules on the planet. The most abundant on the planet. Every living cell on the planet is covered with a dense, complex array of glycans. These glycans form the glycocalyx. Ooh, what's a glycocalyx? I can't wait to find out. In many types of cells, such as in humans, and comprise the cell wall in others, such as plants. Some cells do not have a nucleus, but they all have a glycocalyx. Every molecule, cell, or organism that interacts with a cell must do so in the context of the glycocalyx. The vast majority of cellular and secreted proteins are modified with glycans, which modify, alter, and or control their functions. And what that means is glycans modify, alter, and control cell functions. Did everybody get that? Ooh, you guys are so fast. Okay, so I went to Wikipedia. What's a glycocalyx? Good thing, go. Here it is. Most animal cells have a fuzzy coat. Now, back in the day when we were sitting there in these rooms till 3 in the morning, what we found out was these researchers in the 80s, when they were studying cellular biology, they would see this fuzzy coat on the cells. And see, here's a picture of what I learned in school. See the outside? It's all smooth. Well, what they would do is they would wash off the fuzzy coat. You know, what's this? They washed off all the carbohydrates, and all they studied were the proteins. So they assumed all cellular communication was dependent upon protein interactions. All right? Notice it also says the backbone molecules here. So anyway, so now that they know this, they've changed the pictures, and this is what they're doing in biology textbooks now. The cells all have little hairs on the outside. The glycocalyx is a type of identifier. that the body uses to distinguish between its own healthy cells and transplanted tissues, diseased cells, or invading organisms. It's an identifier. Included in the glycocalyx are cell adhesion molecules that enable cells to adhere to each other and guide the movement of cells during embryonic development. Without the glycans, babies cannot be created. So here's an electron micrograph. Really good picture. This is a healthy cell. What do you see on there? The glycocalyx, right. Notice cancer cells. Now, there's just one, but every cancer cell I've seen with an electron micrograph has no glycocalyx. Now we'll talk about health a little bit. Now, this article had quite an extensive lot of information on health. I'm just going to touch on a few things. The elimination of any single major class of glycans from an organism results in death. You remove the glycans, the cell dies. Glycans are directly involved in the pathophysiology of every major disease. Not just some diseases, every major disease. Every disease that affects humans significantly involves glycans. A great majority of host pathogen interactions involve glycans via recognition, degradation, or molecular mimicry. Do you get what molecular mimicry means? That means that it's on some level, let's say it's a mutated cell, or even smaller at the level of the molecule, it becomes a false signal, a false molecule, a not real, not healthy molecule. Glycans can identify that. In fact, it's involved with glycans. Most protein therapeutics must be glycosylated properly to be functionally effective. Now here's a new word, glycosylated. Now we heard this years ago, right? Glycosylated. What the heck is that? Well, I'll show you in a minute. But isn't that interesting? Now, altered glycosylation is a universal feature of cancer and contributes to pathogenesis and progression. Altered glycosylation. Well, let's find out what glycosylation is. Go back to Wikipedia. Glycosylation refers in particular to the enzymatic process that attaches glycans to proteins, lipids, or other organic molecules. Okay, now we're going to learn this chart. Now this is this is a chart that they use in biology class, and it basically what it does is it goes through the process of how molecules get attached through this. It's kind of a like an assembly line, okay? And each one of these steps takes a lot of energy, by the way, and you result in all of these different glycans down here at the bottom. So that's what they're talking about. It's an enzymatic process. So each one, the enzymatic process is the energy it takes to convert one to another. Each step takes a lot of energy. So now let's review our terms, class. What's a glycan? Any assembly of sugars in free form or attached to another molecule. Any sugar, okay? Next, what's a glycocalyx? The fuzzy coat, a type of identifier that the body uses to distinguish between its own healthy cells and transplanted tissues, diseased cells, or invading organisms. And then lastly, glycosylation, or glycosylation is how they actually pronounce it, the enzymatic process that attaches glycans to proteins, lipids, or other organic molecules. So we have the assembly, we have the identifier, and we have the process. Okay? So get this slide and memorize these words, because it will help. Okay, now let's look at how glycans interact in the immune system. Again, this is from this article. Inflammation is one result of the immune system's response to danger. Immunity is the other. So we have inflammation and we have immunity. The general importance of glycans in immunity has been appreciated for many years, And the early discovered that the ABO blood groups derive from specific glycan structures. Remember that, you guys? We finally looked at it. We went, wow, look at this. These are the human blood groups. And the only difference between all these, the three different ones, O, A, and B, is the glycans on the end. Everything else is the same. Glycans' key role in infectious diseases. I just love this picture. While glycans are important in regulating immunity, they're also key actors in the constant battle between our cells and invading pathogens, including viruses, bacteria, and parasites. So in here we got the differentiation. Are you me, not me? Here's bacterial infection. I don't know what that is, so don't ask me. Viral attachment, cell growth and cytokinesis, cell-to-cell adhesion. Do cells stick together or not stick together? Metastasis. Does it get like weird and become a non-healthy cell? All right, so that's a great little picture. So do you think there's a relationship between your health and the condition of your glycans? Okay, well, I'm preaching to the audience here, preaching to the choir. But the question that came up for me was, is there a way to support the production of healthy glycans so we can enjoy better health? Wouldn't it make sense if our glycans were in good shape, our health would be in good shape? Okay, great. So the factors that may affect the glycan structure and function, and that's what this cellular biology is about. Structure and function, okay? So these things may have an impact. Green harvest, processed foods, preservatives, more toxins in our environment, genetic modification of foods, and pharmaceutical drugs. The truth of the matter is there isn't enough research to say absolutely that these things alter glycans, but it's a real good bet. All right, so how can the body repair damaged glycans? Well, let's see, we could do the pharmaceutical approach. The pharmaceutical approach is very interesting because the guy that wrote this article, that's his audience. Because who funds glycobiology research? Right, not little nutritional companies. So they're going to look for how can we turn this into a drug. And remember, you got one symptom, one drug. One symptom, one drug. They don't ever get at the causal level when you're looking at pharmaceuticals. The vast majority of glycans and glycoconjugates pose significant challenges to synthetic endeavors. They're having a hard time. Over the past 10 years, glycoengineering approaches have provided new routes to producing human glycoproteins with defined glycoforms by manipulating mammalian and other cellular glycosylation pathways, by creating glycoprocessing enzymes with novel properties, and by modifying non-mammalian systems. I just put this in here because this is the stuff they're trying, even though it's a mouthful of words. 10 years, that's the big key there. Okay? Successes, yay! Include humanizing the N-glycosylation pathways of yeast, insect and plant cell systems, and introducing protein glycosylation pathways into E. coli, which is a bacteria. Okay, they're a long way from doing anything to provide us with something that can support the production of healthy glycans. It's just the way it is. So what about nutritional sources? Come on, you can do it. There we go. Okay, Dr. Bill McAnally and aloe vera. Now, this is kind of a little history lesson, but it's going to point out a couple really important things. Dr. McAnally in 1983 discovered the active ingredient in aloe vera, which was a carbohydrate composed mainly of something called mannose, which is one of those sugar molecules. Now remember, what were they doing in 1983? They were washing off the fuzz. They weren't looking at carbohydrates. They were looking at proteins. So this was revolutionary. This man was an original thinker. This is original. He had no validation, no support. But he was going for it. And so what he did was he found a way to stabilize and standardize the aloe vera gel and turned it into a drug. Well, of course. He was a scientist. And it was used with cats and dogs. And they had great hopes for this drug. They actually still have it. But then he was inspired to try a new nutritional version for humans and called it Mannapol, which Mannatech started marketing. Now, the word inspired is underlined. You know why? He had a heck of a time trying to get anybody to understand in the drug world that you could use something nutritional that had a ubiquitous effect. So meanwhile, the science of glycobiology was growing. Remember, we saw that in that dictionary back in the late 80s? So this article came out in 1991. And it says, when cells turn against the body, as in degenerative type functions, research has shown that sugars are missing from their glycoprotein structures. And what did it say way back when? It said, when you remove the glycans, that results in cellular death. Meanwhile, in 1996, Dr. Robert Murray published the first reference chapter on glycoproteins in a biochemistry textbook for medical students. And this is the book, 1996. And what we see, and what Dr. McAnally saw, was there's 8 of these carbohydrate molecules, not just the mannose that was in Mannapol. Now, these are very complicated molecules, by the way, and it's very hard to reproduce. And the reason they can't synthesize it is, look at, there's 416,000 potential combinations, whereas proteins only have 4 combinations. So it would be easy to synthesize a protein, wouldn't it? Very difficult to reproduce or synthesize a carbohydrate because they're very complex. So here's the facts that Dr. McAnally knew. Cell surface structures called glycoproteins are necessary for the proper recognition and functioning of many cells. When the sugars are missing from the glycoprotein structures, cells cannot function normally. Immune cells read the cell surface structures on other cells and determine if they're healthy, need repair, or need to be destroyed. That's what the immune system does. Now, most of us already knew all of this from years ago in Mannatech. Nourish me, repair me, destroy me, protect me, regulate me. This is the immune cell over here. And the cell is saying all of these things, right? And that's the surface structures that are communicating this, all the little glycans. So he developed a hypothesis. He was a scientist. So since a series of enzyme-controlled steps convert one glyconutrient sugar to another, and enzyme conversions require energy, and toxins, stress, drugs, processed foods, lack of enzymes, age, etc. can all inhibit an enzyme's ability to convert these glyconutrients, then is it more efficient to obtain glyconutrients from the diet than have to convert them? What a concept. So he put on his thinking cap. He researched foods that contain glyconutrients. And oddly enough, it's from things that we don't normally have in our diet. Astragalus. We don't normally eat aloe vera too much. Saps and gums. Now, garlic has it. How much garlic are you going to eat, you know? Coconut milk, a few different kinds of mushrooms, not the white mushrooms you get at the grocery store. Pectins from fruits, so you could eat a ton of apples. Some algae, certain herbs, echinacea, and yeast. So there was stuff out there. And he started putting the different ones together, and then he would analyze with it. This really cool machine that analyzes what ingredients are in there and what effect do they have. He did all these different mixtures, and then one year we were on a cruise. I guess it was a cruise to Alaska. Ooh, it was fun, because every morning we would go and stand in line, and he would give us Dixie cups filled with this powder and a little bit of orange juice. And then in the afternoon, he'd have us all come back and say, so, what happened? What was it like for you? And we're all going, ooh, I feel this, or ooh, I feel that. It was a very exciting time. Lots of good research there. So in 1996, Ambrotose was born. And they had to name it. Now, they already had Mannapol, so they couldn't use the word manna. So they came up with ambrotose, which is a combination of ambrosia, food of the gods, or manna, and os, meaning carbohydrate. Ambrotose. And it took us a long time to learn that word. So then we're going, okay, I wonder if there's any research out here. Is there anything we can do to figure out if what we're saying is actually true scientifically? And so this article came out about breastfeeding. And what it said was, after 5.5 months of breastfeeding, in infants, it could prevent allergic diseases, long-term protection against diarrhea and ear infections, protection against the flu for up to 10 years for a child, activates the immune system to function more effectively, giving better protection against infections for years. There's less of a risk of developing allergies, autoimmune diseases, and inflammatory bowel disease. Remember, back then, in the era I was born, they were down on breastfeeding. They wanted to give everybody a bottle. Okay, well, what are you not getting in a bottle when you're feeding a baby? These wonderful protections in breast milk. And lo and behold, the picture happened to show glycans with the exact same molecules that was in Harper's biochemistry and that's in ambrotose. Okay, now we got the critics. Because if you're going to have a natural product that works, then the scientific community and the pharmaceutical industry are at risk of having a little piece of their pie taken away. We don't want that. So they began to start to attack Mannatech. And here's the first attack. It said, can the ingestion of glyconutrients convert to glycans? Well, in 2011, this one's from 2011, and they had some other stuff a little bit before that, but I love this statement. For the first time, science has shown that the ingestion of a standardized blend of plant polysaccharides, ambrotose powders, can induce significant changes in glycoprotein structures with no adverse effects. In fact, it doesn't even raise your blood sugar. A sugar that doesn't raise blood sugar. That's pretty cool. And then Mannatech thought, hey, let's do some research of our own. And they started this wonderful thing, and you can look at all of these studies on mannatechscience.org. Now, I don't have enough room on the screen to show you the whole thing, so I'm just going to show you the highlights. First of all, shortly after taking a single 4-gram serving of classic ambrotose, healthy adults experience significantly improved memory and perform significantly better on demanding cognitive tasks. The next one is significantly improved memory and improved psychological well-being. The third one is a single 1 tablespoon serving of ambrotose complex significantly improved visual discrimination and working memory. Now I want you to think about this. This is the brain. And your brain, if any, I used to study psychopharmacology just for fun when I was in graduate school. And what we learned is it's extremely difficult. The brain is so complex. There are these neurotransmitters in there that generally determine how you feel about yourself. There are also hormones in there. There are also these other, like there's a blood flow. There's a lot of things that determine memory and cognition. So if there's something that you can take that's a natural product that affects cognition and memory after just taking 1 serving, this is significant because the brain is the hardest thing to change. But just think what it's doing to the rest of your body, because remember, the glycans are ubiquitous. They're everywhere in your body. And then they did these double-blind placebo studies. A single 7-gram serving of ambrotose improved memory. 1 tablespoon serving of ambrotose enhanced brainwave frequencies known to be associated with attention or alertness, and this was done on college students. So we're not talking about the old people that have cognitive decline. Obviously it could work there, but what about young people? If you can affect the brains of the young people that have healthy brains, just think what happens over the aging process. 1 tablespoon serving of Ambertose improved mental reaction time and enhanced concentration. They did preclinical studies with Ambertose. Ambertose powder exhibited prebiotic effects along the entire colon, which is really important because up to 80% of your immune system is created inside your intestinal tract from the food you eat with the bacteria that you ingest. So this is very important. The intake of advanced Ambertose powder had positive effects in the brain on the expression of genes associated with the regulation of learning, memory, and mood. These preliminary findings indicate that the intake of Ambertose products provides significant cognitive benefits to healthy adults. And, like I said earlier, it does, you know, because they say, if we say sugars, people right away freak out. Oh my gosh, it's going to raise up everybody's blood sugar, and oh my, I might become diabetic from it, or, you know, whatever they think. But the truth of the matter is, Ambertose will not cause an increase in blood serum levels like other carbohydrates that go down the glucose pathway. It's very important to know that. So here's Ambertose. 50 patents worldwide, and these are all the things that we can say about it. It supports cellular communication, improves cognitive function, improves memory, improves concentration, improves attentiveness, improves mood, decreases irritability, supports immune system function, and supports digestive system function. Now, doesn't it make sense to take Ambertose? Well, these are our heroes. Dr. Bill McAnally, the original thinker. The guy whose mind was so unadulterated by or influenced by the standards of the day, the way of thinking of stuff, he was able to change the world. Sam Castor, whose vision of Mannatech and his ability to see the value of Dr. McAnally and his products created the biggest nutrition revolution this planet has ever seen. And finally, Dr. Rob Sinnott, who carried the torch, who's continuously developing better and better congruent ways of showing how glyconutrients can impact health everywhere from skincare all the way down to the basic molecules of life. So now it's your turn. You can carry the torch too. You can share Ambertose with people. You can take this presentation or other presentations and just show people how ubiquitous Ambertose is, how important glycan structures are, and how people's lives can be changed. And also I just want to do a shout out to Greg and Doris LaRock and Doug and Mary Wickham, who have sustained Bill and me through all these years. Loyalty is something amazing. Loyalty, stick-to-itiveness, and belief. So thank you guys for being here, and thank you guys for being here.